how does the system respond or adjust itself to the effects of that change is what we want to discuss now. Let's say, for example, you have nitrogen reacting with, you have nitrogen reacting with hydrogen to give ammonia. Okay, this is in a gaseous form. This is also in a gaseous form. This is also in a gaseous form. So, and let's say this like this. For example, let's say it's an endothermic state. For it to be in equilibrium, it has to be in endothermic state. Usually, you have to always balance. If you want to balance, this is 2, this is 1. Okay, what if you put 2 here? Hydrogen will tend to be 2. Okay, it's also 2. Hydrogen will not tend to be 6. This is hydrogen that's 2 times 3, that's 6. Then you put 3 here. Hydrogen is now 6. Hydrogen is now 2, so it's not balanced. So whenever you have this, let's say the system is already balanced, it's already in the state of chemical equilibrium. You now apply concentration. You now increase the concentration of nitrogen. So we want to explain concentration first. Let us explain concentration first. We want to explain effect of concentration on this equilibrium system. Everything is in your notes, don't forget. So there's no cause for alarm. So you can just, you have seen it in your note that what I put here is effect of concentration. So let's say this system is balanced, it's in a state of equilibrium, and you want to explain how the concentration, okay, how this concentration now affect the equilibrium system, and how the system itself adjusts itself to neutralize the effect of applying concentration. And that's exactly what to do. We do it for concentration, we do it for pressure, and at the same time we do it for temperature. So if you have this, you now increase the concentration of, you can increase the concentration of any of the two, or this. You can increase the concentration of any of them, either this or this or this, or increase this and this, and decreasing this, or you increase this, decrease this, or you just increase one. Maybe you increase one. So increasing all of them at the same time, decreasing all of them at the same time, increasing one and decreasing one at the same time or at different time, okay, will always affect the system. But what is the system doing to adjust? Okay, how does it do it? According to the Lechatelier principle, we have explained what the system does. But how does it do it now is what we want to do. Anytime you increase the concentration of any of the reactants, either you increase the concentration of nitrogen, that means you are putting more of nitrogen. Anytime you increase the concentration of hydrogen, that means you are putting more of hydrogen. Okay, either of the two. Anything that will make you to increase the concentration of nitrogen, okay, or concentration of any of the reactants, will always tend to produce more of the product. Okay, so increasing the concentration of any of the products now, these are the likely things that happen. Okay, more of product is formed. More of products is formed. Okay, you can also say forward reaction is favored. Forward reaction is favored. Forward reaction is also favored. Okay, so these are the things, these are the ways they will ask you. More of product, or you say more of ammonia is formed, or more of ammonia is produced, or you say it favor forward reaction, meaning that the reaction will proceed forwardly. It proceed from, or you say it produces from left to right, or you say it proceed from left to right. These are the ways CHAMP can change, can change their words. All of them are the same thing. They are saying the same thing. So when it's moving, it means that it's favor forward reaction. That means it's clear. Anyway, so I hope you are understanding me. Hope you are understanding. Okay, now, so let's continue. If this first one that we did now is if you are is if you are increasing the concentration of any of the reactant, increasing the concentration of the reactant, increasing the concentration of the reactant, any of the reactants. Okay. Now, if they are increasing nitrogen, these are the things that I said will happen. If they are increasing nitrogen too, these are the things that will still happen. Okay, that's for. Now, if you are not increasing product, if it is product that you are increasing, instead of increasing the concentration of reactant, now, let's say you are not increasing the concentration of the product. Let's say this is the what? This is the product. You're increasing the concentration of the product. What happens? That means it's just the opposite of all of this. Okay, it's now products that are now increasing, so it will be opposite of all of this. That means it will proceed from the right to the left. So now this one now we proceed to move from the right to left. Okay, or you say it favor backwards reaction. Okay, favor backward reaction, or you say backward reaction is favored. Trying to see how I can shorten the word. Backward reaction is favored. Okay, or you say more of reactants are formed. More of reactants are formed. You have all of this in your note anyway, and you can hear me very well. For those of you that are not seeing, okay, but I can see that it's very increasing the concentration either of the reactant or of the product. So now here now you are decreasing. You are decreasing the concentration of the reactants. So if you are decreasing the concentration of the reactants, what does it mean? It means you are reducing this, you are removing this. Those are the words that Jan will be using for you. You are removing this, you are decreasing this. Those are the words they will be using. Reducing, that means if you are removing, or you are reducing, or you are decreasing the concentration of any of the reactants, what happens is the reaction is still favoring here, because where you have more of it to produce is where the reaction is favored. So if you are removing any of the reactants, the reaction will favor where you are removing. That is what is happening. When you are removing, that's where the reaction will favor. So favor, that means it moves from where? Right to left, because it's favoring left. You see it moves from right to left. What is very important is where is more of it produced when the equilibrium is disturbed. When you disturb an equilibrium system, where do you now have, where is it favoring? So I said that here now is what you are removing, and I still said that this is where you still have more of it being produced. So that means it's favoring here. So that means it has to now move from the right to the left. So it means it moves from the right to left. It means it favor backward reaction. That means backward reaction is favored. Or what do you say again? More of reactants are formed. More of reactants are formed. These are the words that JAM uses. These are the words they use. So all these words you have to master them. So this is how concentration affect equilibrium, and how the equilibrium also adjusts itself, also respond to the effect of applying the concentration. That is that. So in the next class, we'll explain how temperature and pressure affect an equilibrium system, and how the system also adjusts or respond to the applied factors. So to those factors, how pressure and temperature affect it, and how the system too respond and adjust to it. So